control and software. All right. So again, what is our traditional way of controlling the sensors and actuators? Right. We used to have a centralized compute unit. From there, we go for different domain issue. ECU for BCM, ECU for infotainment, ECU for ADAS. Each one of these domain issue will connect to a number of sensors and actuator. Right. So this particular system is something a signal based one. Control loops mostly in domain and central ECU. So either the control algorithm or software is here or here, right? So it is a centralized control, many point-to-point signal, control loops in domain or central ECUs, high network load, less modular and scalable. These are the characteristic of existing domain-based architecture, right? What sort of characteristic the zone architecture will have with respect to control and software? They used to have a centralized compute unit that will be there, and then there is different zone modules for every zone: front zone, right zone, left zone, and rear zone. Right? Sensors or actuators required in that particular zone are connected with that zone control. So it brings in distributed control. Service based architecture, control loops moved to zone module. So they are not in the centralized compute unit. So they are coming to zone module. So they use a service based architecture, right? Real time control loop in zones, lower bandwidth need, more modular and scalable. These are the advantage that we get when we move the control to the zone, right? So again, what are the challenge? What are the solution for that? Re-architecting software and control strategies, ensuring the real-time performance, determinism, and functional safety in the distributed environment. These are the challenges that we have in the existing one. How it is addressed: zone module hosts the real-time control and services, reducing the central compute load and improving the scalability, over-the-air update, efficiency, and flexibility. These are the advantages that we have in zone architecture with respect to control and software, right? Then the data plane topologies, right? So in existing domain architecture, we have different bus systems like CAN, LIN, flux array, automotive Ethernet. These are used to exchange the information between ECUs, right? Their bandwidths are limited. So if you take CAN, if you can go in the traditional CAN, you can go only up to 1 Mbps. In FD, it is 5 Mbps, something like that, right? So only you can go up to that, right? They are limited. Their bandwidth is limited, right? Some of them were point-to-point. So automotive Ethernet, it is a point-to-point connectivity. Then limited scalability, not optimized to mixed data type. So they are not optimized for to handle the mixed data type, right? So when it comes to this zone architecture, we have different options. We have automotive Ethernet with multiple speed like 2.5G, 5G, 10G, right? Time sensitive, network ready. So those sort of things are the advantages that we have in zone architecture. These high speed bus system techniques are used to exchange information from zone to centralized compute unit. The mixed data type, high bandwidth, scalable topologies, right? Deterministic with time sensitive network, optimized for sensor, video control, and service data. These are for those it is optimized, right? Again, challenges that we have in like centralized architecture or domain architecture: migrating to high-speed network, new files, and complex topologies while ensuring the reliability, latency, and EMC. These are the challenges. For that, the solution is they use a high-speed Ethernet backbone with a new files and TSN enable resilient, scalable, and efficient data communication for all type of data. These are the challenges and the respective solutions that we have in the zone architecture. Summing up all the point, right? The zone architecture provide high reliability and safety, lower weight and cost, scalable and future ready, better OTA, diagnostic and services, optimized energy use, right? So they are more suitable for battery enabled vehicle and the hybrid enabled vehicle, right? So that's all about the real world challenges that we face with respect to zone architecture. Okay, team, that's all for today. We can stop today's session with this. Let me know if you have any comment on this topic that we discussed today. Thank you. Thank you for watching.